in highly dynamic ecosystems. Please note this workshop will be recorded and the keynote presentations will be made available online for public viewing later on. We will also record the Q&A and discussion, but only for the purpose of note-keeping. If you do not want your question or discussion to be recorded at all, please send an email to the steering committee within the next 15 minutes. If we receive any objections, we will just not record the Q&A and discussion for this workshop. Just some brief housekeeping for the workshop. So first, please keep your mic muted and camera off while presentations and discussions are going on. Questions will be taken at the end of the presentations. And if you have a question or comment, please type question into the chat, and we will call you to ask the questions. And also, if you prefer to type your question into the chat, we can ask the question for you if you want, so that you don't have to introduce yourself and ask questions by yourself. Also, please keep your questions succinct. And if time permits, we will open the floor to more general comments and experiences for the discussion period. And also, please find the Google Drive link here, which we will deposit the presentations and other documents after the workshop. So right now we have the workshop agenda and Andre's presentations from yesterday in the Google Drive. So if you are interested, you could go there and check on the presentations. Okay, so today we are pleased to invite Dr. Anna Rindorf to give the keynote talk. The title is Reference Points in Non-Stable Northeast Atlantic Stocks. Dr. Anna Rindorf is a professor at Technical University of Denmark and the head of section for ecosystem-based marine management. Her work aims to incorporate biological knowledge of fish stocks in operational management advice. She focuses on investigating and modeling ecosystem impacts of fishing and developing indicators of fishing impact and ecosystem status. A key component in her work is the operationalization of indicators in management, considering both ecosystem, economic, social, and governance aspects. She is currently the daily leader of 35 scientific staff working to improve ecosystem-based marine management. Okay, so now I will turn the mic to Anna to start her keynote presentation.
Thank you, Fan. I'll just make it work with sharing. So, do you have the slides?
Yes.
Great. Okay, so thank you for giving me this opportunity to speak about the reference points in non-stable Northeast Atlantic stocks. And it's actually quite funny because that's basically all of them. So I can just talk about whatever stocks I would like. First of all, I was just thinking that it would be nice that we agreed on which reference points we were actually interested in. Unfortunately, you don't actually get a say in this, but I'm going to tell you which ones I know something about, so which ones I'm going to actually say something about. And what is actually changing? Well, lots of stuff is changing. The map here below shows the temperature changes, and here it's pretty clear why I work in the North Sea and the Baltic Sea, and you in Canada are interested in changing environments, because it's really one of the heating, or of some of the heating areas that are rapidly heating. I think the west coast of the US are a little better off than this one. So lots of temperature changes. What are the reference points that we want to look at? Well, all of the areas use a combination of fishing mortality and biomass reference points. So that's basically what I'm going to talk about. And if you look at Fs, it's something like FMSY that's related to it, but not exactly FMSY necessarily. That's all over the place. So if you look at the Barents Sea and the areas around Iceland and the Faroe Islands, and also the Canada implementation, they have an so for Norway, for example, have an they need to have FMEY actually, but they're sort of doing MSY, and it's sort of they have a little bit of wiggle room that we don't actually have in the EU where I work. So I've called it MSY-ish because it is MSY, but it's not in the same strict definition that we're using in the EU and in the US. In the US, you have the requirement to fish below FMSY, whereas in the EU, we have the requirement to fish at FMSY. So there's a little bit of how we actually use them, but the values are the same. So it's worth looking at. If you look at biomass reference points, things are more different. So I've called them action points. It's basically where you change your fishing mortality. Which biomass does that happen at? And if you look at the Canadian and the Norway EU areas, it's something about a reference point that is related to a stock recruitment plot, plus something precautionary to stay away from bad things would happen. The US version, you have some fraction of BMSY, not necessarily 0.5, but it's somehow related to either virgin biomass or BMSY, but not necessarily directly to the stock recruitment plot. So what's the difference? I mean, theoretically, maybe it's the same. Typically, BMSY is the output, the average biomass that comes out of simulations. So some kind of a management strategy evaluation or a simulation that puts in biological parameters. So you've got all the weight and the natural mortality, all that stuff going in, selectivity pattern, and a stock recruitment plot. So the stock recruitment influences BMSY as well, but it's not the only thing going in. The stock recruitment based reference points are based on the stock recruitment data and the assessment uncertainty, but they don't include the biological parameters apart from this, and no selectivity pattern. So no weighted age and natural mortality and all that noisy stuff. This is a simulated one from a paper from Michael van Deurs, and it's basically just showing how they always look. So if you are lucky that your stock has been somewhat overfished at some point, then you probably have some points in the lower area of the curve, but often you mostly have what looks a little bit like no relationship at all. The curve also shows some potential candidates for the biomass below which you're going to have trouble with your recruitment. So we're basically looking at which is the place that we really don't want to go because it'll give us problems having lots of fish next year. But trying to find out from something a little bit noisy like this, it's not actually straightforward. So there's a range of indicators that have been suggested and versions of this, and also on the plot there's also the fraction of B0. So lots of those different ones, but you can see in this plot that they're actually not necessarily similar. They might be quite different. And if you look at what happens to these indicators when you estimate the indicators for different time series lengths and the stock development, this is a typical one for stock development. If you start out having a stock that is at a low biomass and increasing, so you're observing your data points, you know, before the breakpoint, at the breakpoint, and then further to the right, then you actually don't necessarily have a bias in your estimate. But if you start out, which most of the stocks did, with a very high biomass, and then you started fishing a little too much probably, so you were at a decreasing stock, then you actually start out having no information about the breakpoint. And as you move, so you have basically, you're trying to estimate a breakpoint you don't know anything about, which means you have a positive bias from all the methods in your estimation. So you are basically guessing the reference point to be higher than it is in your actual simulated data. As you get more data, so the fishermen are being helpful and we get a bit much lower stock, you get some information about the breakpoint, so you can actually be pretty accurate about what's going on, depending, of course, on the variation in the data. So that's basically, yeah, same. So if you look at what an actual data example could be, this is the reference point for the Prince Rupert Pacific herring, and it's for 3 different methods. And the one on the right is the hockey stick, which is very common. There's also, you know, the riggers and the other ones, but they basically have more variation than the hockey stick. So this one shows the hockey stick and 2 versions of when is the lowest recruitment that occurs with, you know, more than a median recruitment that occurs in which biomass, and then it's more than the 80% fraction of the recruitment, which biomass does that occur at, the lowest possible. So different versions that have been used by different people. And basically, I have chosen this one because it shows that if you have less than 20 years of data, you actually have quite a bit of variation. It doesn't really matter which one of those indicators you choose, you get quite a lot of variation. And also, it looks like some bias that you don't actually want. You would prefer to avoid, at least. And also that you can see very clearly that the reference point that we estimate for this one really depends on the method we're using. So one of the things that's often not really specified clearly, because it's often relying on the data and you have to make some judgments. So some judgments leads to a lot of impact, and you have this problem with needing a lot of data. If you have a system, which most of us have, where you have regime shifts or breaks in the productivity or the stock recruitment time series, some kind of stock trend, then you basically often break up the time series and look at shorter time periods. So if we just keep in mind that having less than 20 years of data is likely to be noisy, not just for this stock, but for all the simulations. Let's have a look at the Cody-Sawalski's paper here about the average regime length by different groups. So basically the average regime length is 7 to 11 years with a pretty large standard deviation. So probably some of them are nice stocks that would be more than 20 years, but on average, 7 to 11 years, which is actually less than we can estimate the reference points from. So we really have a problem between, or a conflict between, what we need in data points and what we would like to estimate. Yeah, but that would all be solved if we just use some fraction of BMSY or virgin biomass. Then we could just, get rid of this problem, maybe. Well, unfortunately, they don't actually provide the same results, which has led to a lot of mine is better than yours discussion. But I think it's not necessarily what's better, but it's nice to know the difference. So if you look at these are data from an ISIS workshop that did MSY estimates from simulations for the North Sea stock, the Baltic stocks, and the Barents Sea stocks. And basically, the x-axis is showing the stock recruitment-based reference point with the PA buffer, so some reference point that you have used there. And the other one shows half BMSY. I know that we sometimes use 40% and some other fractions, but it's just to show what's happening. The yellow points are pelagics and the white points are demersals. So if you look at the figure, you can see that the yellow points tend to be below the red line, I should say, is just 1 to 1. So that's where everything is equal. And if you lie below the yellow line or the red line, then your reference point is higher with the recruitment than with the BMSY. That means that if you aim for the BMSY version, half BMSY, you may actually have an impaired recruitment, even though you have MSY at this point. So it's not true that you can never have a BMSY where you didn't impair recruitment, because it actually happened in these stocks for the simulations with actual data. If you look at so that was the yellow one. So we might have some issues with pelagics, and it doesn't necessarily matter if you don't have a lot of pelagic fisheries, but actually we do in the ISIS area. There's quite a lot of big pelagic fisheries. If you look at the white dots, these are the demersal stocks, and possibly for them, it looks like the BMSY is higher than the stock recruitment relationship-based reference points. So possibly if you're basically using your stock recruitment to decide when to decrease your fishing mortality, so when to take action, you may be actually acting too slowly to ensure MSY. So you might actually have an error in the other direction there. If you look a little bit further on the white points, however, these are 2 stocks of cod, highly cannibalistic and currently depleted cod stocks, which are ignoring that the cods are cannibalistic. So you're basically doing the simulation with the current natural mortality and the current growth, and then you don't really worry about that these will change in the future. So whether they are actually overestimated when you actually include the true relationships, that's also possible. So, and it's not a lot of points. So, but anyway, it seems that they're not necessarily the same. So you cannot conclude that just because I have half BMSY, my recruitment is okay, or just because I have my recruitment, I'm above half BMSY. So not identical. I'm still going to use the stock recruitment based one, simply because it's the one that's in use in ISIS, but I also find that it's a lot easier to explain when I get pulled out in front of the press to explain why can I not, why can these fishermen not keep fishing this specific stock. Then it's actually quite easy to explain to them that that if you fish further, you actually impair your next recruitment, and that's most people can see that that's not a good thing. So moving on with the stock recruitment based ones. Let's have a look at pelagics. So why is it actually that the pelagics, the stock recruitment reference points, are generally larger than the BMSY based ones? Well, it has to do with the way the stock recruitment plot looks for most pelagics. This, the figure on the left, that shows the steepness. So it's the proportion of your maximum average recruitment. So if you take one of the curves on the right and predict your recruitment from it, and then find where that's maximum, then what's the proportion of that maximum you're getting at 20% of your virgin biomass. So you're basically messing around here at this area here and see what is the predicted average recruitment in this area. If your curve here is very steep, so then you get a very high proportion of the maximum recruitment already at 20% of virgin biomass. And if it's very sort of shallow or not increasing so much, you get a low proportion. And these are it's from a meta-analysis we're working on, but it doesn't have a lot of flatfish, so let's ignore them. But for demersals, you generally have almost all of the recruits available already at 20% of your virgin biomass, but that's not the case for pelagics. So at pelagics, you might actually be around 50% of your maximum recruitment. So there's something different in the way the stock recruitment plots look. So if you imagine that the one on the right is some demersal stock, a cod stock or something like that, and you look at what would it look like for a pelagic fish. Well, basically it's equivalent to removing these points. You have an ever increasing relationship, or at least it's increasing for a lot more of the observed biomasses than in the cod case. And I don't think this doesn't have to do with the fact that we killed all the pelagics, so we've never observed the virgin biomass. Actually, pelagics are very variable in biomass, so we have a pretty wide range of biomasses for them. So that's not actually the reason. It seems that the way they reach the carrying capacity is different from what happens in demersals. So we need to think about the pelagics again. But why are they even important? So I get this question a lot, but we're doing BMSY now, so we don't actually need those reference points, because in theory, we have rebuilt all the stocks by 2020, so that's last year, and they are now all doing fine, and we don't need to worry about it. Well, actually, biomass reference points have a direct impact, obviously, on the depleted or decreased productivity stocks, but also on pelagic and short-lived stocks advice. So because of this thing with the stock recruitment thing for the pelagics, they tend to be messing around somewhere around BPA. Just a specific note on short-lived stocks. So we have a lot of fisheries, or pretty large fisheries, for short-lived stocks in Europe. And basically, the ISIS accepted management strategy for them is that you do not fish unless they're above this specific biomass point, and then you only fish them to the specific biomass point. So it's different from an FMSY approach. It is in simulations the approach that provides you with MSY, but it's not a fixed F approach. It is added, so it basically, for a long time, there's no fishing, lots of closures in those fisheries. And then there is an increasing fishing mortality up to a cap that's introduced because we have issues with the big variability in recruitment. So if we didn't have this cap, it becomes unprecautionary because of these very large recruitments coming in, or actually because of us not being perfect at observing very large recruitments. So they have a special one, that's the purple one there, that's for short-lived stocks. Typically, they are managed to leave this specific biomass in the sea, but it's so that the annual F varies according to the current productivity. So you have the most recent data you can get your hands on, and that's what you're using. So different from FMSY. If you look at who are actually, or which stocks are actually messing around close to BPA, this is true for the pelagics, the short-lived, and obviously everything where productivity is suddenly halved, it tends to end up in this area, making the biomass reference points really important for those things. And if you look at the demersal, long-lived, high productivity stuff, everything that has a very low FMSY, that tends to end up far away from the breakpoint. So it doesn't really matter so much in theory for cod, if we could just rebuild them, they would be far away. But there are quite a lot of stocks where you still need to think about recruitment impairment even if you're doing your FMSY, by the book. Okay, so what do we do if stuff is changing? Since I was just saying that the reference points are so difficult to estimate, and we have all this with the regimes being shorter than what we need to estimate, can we just, let's just not do anything that's simpler? Well, this is an example for an increasing stock, because we have those too. This is placed in the North Sea. That's basically like most of the place stocks going through the roof. If you look at what happens for increasing stocks, they basically keep the stock recoupment-based reference points, but in a few cases they have replaced them by some fraction of BMSY, or the biomass that provides you with MSY in 95% of the cases. So you get some kind of increase there. So that's the red line you see in the plot there, whereas the previous action point for a biomass, so where we change the fishing mortality, is the dotted line. It's now much higher. It's also very far away from where we are now, so it's not really relevant actually what happens to that reference point. Most stocks, they actually just leave them, and I think that's partly because we're so far away, it doesn't really matter anyway, so they're just left. So no impact on the management. Actually, it does cause some attention. So if they are not increased, then we get quite a lot of comments about why we're not using BMSY reference points. So, and why they are so low when they should be increased. And if they are increased, we get concerns from the industry, because the industry is then a little bit worried that what happens if we go into low productivity again at some point, then we have this really high biomass point. So it gives you some comments, but generally they're not actually changed. So all the discussion is about declining and low productivity stocks, or stocks that are severely overfished. So that's where it's worth keeping in mind that that's where all the pressure is to change the biomass reference points. And this is a good example of something that has declined a lot. It's North Sea cod, and it's the stock recoupment plot on the left, and then it's recoupment success on the right. You can see it doesn't look too good for the cod. Probably it has some issues with temperature and other things. It also has, part of the decline is actually caused by cod maturing faster. So we have an increase in spawning stock biomass that doesn't really seem to yield nice recruits. So this is the stock recoupment plot. If you ask the model, you can ask it to do a hockey stick. That's the solid black line. And it comes up with a breakpoint in the sort of high end of the data. If you ask it to do Ricker or Beaverton Holt, that's the dotted line. So it's basically doing a linear increase, and it's not really giving you any information about the breakpoint. So what do you actually do when you sit there? First of all, you can discuss whether you need to accept the very high breakpoint that the model tells you, or you do something else. And to complicate the thing, this is the good old times. So that's the 70s and the gadoid outburst, some of the 80s there as well. So when the stock was good, and then naturally the rest of the points is where we are now and where we've been for a long time. So we don't really know if what happened was that in the good old times, we had this green line here, which had a high productivity, but the same breakpoint as in the total time series that we're looking at now. And we then changed in the recent times to something which has a lower productivity, but the same breakpoint. So we don't really know if that's what's happened, or what happened was that we had a change in carrying capacity. So basically the breakpoint is now at a much lower place. So you can see that it's about half what it used to be in this new yellow dotted line. And I should say that I could have done the Rickers. It's the same discussion for them. It's just about the shape or the height of the curve. But since the Rickers don't actually fit, and the Beaverton Holts don't fit the stock, I've worked with the hockey stick, and I am aware it's maybe not the biologically most reasonable relationship that you would expect. So what did the working group actually do? There was a benchmark in 2015, and they had all this data, and they were all confused, and they did some tests, and it's not surprising, but the tests were not very strong, so it's difficult to conclude something from the tests of the breakpoints. They ended up deciding that this was the last big year class that we had observed. And so it looked like you could get above average recruitment if you just had a biomass of around 100,000 tons. So they ended up thinking that that was a good candidate for decreasing recruitment. But basically what it was is it's expert judgment. It's not a model. Let's ask the model, because the model result seems to be very, a bit uncertain at least. And it wasn't just about avoiding a very high biomass that hasn't been observed for more than 10 years in total. It was about trying to figure out whether these are actually, is this actually the biomass that would give us reduced recruitment? So that's what they have now in the reference points. All the MSY calculations for this stock, they go on with the other stock recruitment plot. So they don't use the reference point necessarily in FMSY, but it's used to estimate if we have to take some action on fishing mortality for cod. So what's done in general? Well, there are quite a lot of depleted, decreased productivity stocks, which are looking at the biomass reference points. Mostly they do like this one, they do expert judgment. So, and mostly they get this problem. We can't actually test. We would like to, but it's not really a strong test. A few cases, they try to adjust for assessment model variability. So in some of the models, you have this problem that it will shift all your biomasses up or down by 10 or 20% every year, which is really annoying for the stock status relative to your biomass point, because it'll then shift, from above to below. So they basically scale everything to the relative to a specific year to account for the assessment model variability, but they keep, from a biological point of view, it's the same reference point. Most of them, they use all the data or more than 20 years to support the biomass reference point. But actually, there are exceptions. So there is one stock where they have decreased recently the biomass reference point by 55% based on 12 years of low productivity. So 12 years of stock recruitment plots out of a total of 25 years. Yeah, and you can't help but wonder if that was the correct response to low productivity. All of these cases have passed external review. So to me, it sort of indicates that the reviewers are equally confused, and mostly the reviewer reports are stating exactly this. We think it's a little unclear how we're supposed to set these reference points in the best possible way. And it's fine that you have expert judgment, but maybe a little more guidance would be useful. Okay, so that's the biomass and why I think it's still interesting to look at it. But let's have a look at what everybody's mostly working on, which is the fishing mortality reference points. And how should we change those with productivity? Well, I'd like to list a few common expectations that I meet a lot when I ask people, like stakeholders there, or fishers or other people, what they think will happen to FMSY as the productivity changes. So they generally expect that if there's a low productivity in the system, you will fish less. So they don't necessarily phrase that as you will have a lower FMSY, but that is the expectation, that you will fish a lower proportion of the stock because it has lower productivity. There's also a general expectation from NGOs, green NGOs, that if you include enough ecosystem considerations, you will get a lower fishing mortality FMSY. So just, the fact that we didn't include the ecosystem considerations and the density and all that stuff means that we're actually having a too high FMSY now, and we should include it, and then it would all be decreased and we would all be happier. And there's also a general expectation that as long as we fish at FMSY, we don't need to worry about the rest. So as long as we would fish at FMSY, we could, we'd have enough of all the fish of all the stocks. So it's nice to keep in mind what do people expect to find out of this before you just check what actually will happen. So let's examine. So basically, this is you have to imagine we've done an MSE. That's the guy in the corner. He does the MSE. I do the colorful plot. This is a North Sea cod-ish MSE. So it's basically the weights and natural mortalities and selectivity pattern of a cod-like fish. And they typically look like this if you look at the yield as a function of fishing mortality. So the landings, not the catches. You have some top here, which is the MSY. It occurs at FMSY, so there's nothing new in that. If you fish above the FMSY, you initially go into growth overfishing. So it's equivalent to harvesting your cows or your pigs before they reach a marketable size. So you're basically killing them, but it would be better to leave them out there to live a little bit longer and grow a little bit more. So growth overfishing. And then at some point you reach this point where we used to be all the time, which is the precautionary fishing mortality, where you get recruitment problems. So you get growth overfishing and then recruitment overfishing. And we really would like to avoid, because having tested overfishing, we don't want to do that again. So we really would like to avoid falling down the slope on the right side. Okay, so what actually happens if we change growth? How does it affect your MSY. So this is basically the same curve, but everybody goes slower. So what you can see is that the MSY, the yield, is falling, but the FMSY is not actually falling, it's increasing. The precautionary F, however, is decreasing. So you get a change in FMSY, but it's kind of dependent on where you are with your precautionary relative to your maximizing part of the curve. So you can't actually conclude that it will increase or it will decrease. Mostly it actually increases if you have a lower growth. If you look at recruitment, it's the same thing. If you have lower recruitment success, but the same curve or the same shape, you get a increase initially, an increase in the FMSY, and then you get closer to the precautionary reference point. If you change the shape, something else happens. So you can't actually, know for certain. Well, maybe you can, but I can't say for certain what's going to happen when you change the shape of the recruitment pattern or the recruitment relationship. If we look at things like natural mortality, it's almost the same story. So if you increase the natural mortality, you get a lower yield. It occurs at a higher fishing mortality, and the precautionary F is decreased, so you can fish less without causing recruitment problems. So points going closer together, and you don't actually know in which directions the FMSYs are moving. We saw a lot of examples yesterday about weighted age changing and recruitment changing. So I'm not actually going to show you any examples of that. You know that happens all the time. But the natural mortality is a little bit different. Oh, that was basically saying what I just said. Does it actually change? We can have a look at that. We didn't see anything much about that yesterday. So this is a plot of the annual predation mortality of North Sea cod. And the different colors are the different predators. The years are from 74 to 2019. So it's fresh off the press in October. It's a stochastic multi-species assessment model. It has 25 species, 10 of which has full assessments. And it's published basically every 3 years by ICES. There's a peer-reviewed version of this with all the data fancy online. So who's basically eating the cod is what we can see here. So we have cod age 0, 1, 2, and 3. And you can see the scale of the graphs are different. So it's very dangerous to be small. The smaller you are, the more dangerous along the way. But let's have a look at who's actually eating them. Well, this one's actually a small gray gurnard that actually eats a lot of juvenile fish. But we don't really see those fish much. O group is not caught in the fishery, so it's included in the model, but it's not so relevant for the surveys and the fisheries. If you look at the H1, new ones come in. So new predators are there. There's a big like pale blue thing. That's cod. You can see that we have managed to assist in reducing the mortality of juvenile cod by overfishing the cod, so we don't have a lot of cod left, and basically not rebuilding it as well. So we still have pretty few big cod, which means that they have a lower natural mortality from that source. But let's have a look at the other colors. This one, the yellow, that's porpoises. We just recently, within the last 5 years, we included mammals in the model, and porpoises seem to be very, very efficient at picking out cod. So, and gadoids in general. So they really like gadoids, and we find both the otoliths and the whole fish, because they don't chew, they're not like seals, they just swallow things. It's a small dolphin, so it doesn't really chew much. But we find whole cod in their stomachs. So they basically eat a lot of gadoids. They also have very little change in their abundance and in their diet composition. So we have years of data from them, and it looks like they just they don't worry about cod disappearing because they're pretty able to get hold of them anyway. So, and then the final one, which is always popular, is the turquoise one. That's this guy, gray seals. Gray seals have shown exponential growth in the North Sea in the time period. So they basically become increasingly important. And cod is one of the ones that are included in the F range where we use to estimate FMSY. And if we compare, that's the FMSY of cod. So, basically seals are a pretty big predator and on the cod and have become increasingly important. But you can also always worry, because I really like those graphs. They're so nice and colorful, and I really like the model. But is it, just me that's like led astray by loving the model? That can happen to people with lots of data. Let's have a look at what the actual data without the model will tell us. This is a Norway pout, which is a small prey fish in the North Sea. It's the total mortality from survey data, and then on the y-axis, and then it's the predator biomass in the North Sea on the x-axis. So it doesn't have any model underlying it. It's simply the sum of some biomasses of gadroid fish, and then the observed decreases in the surveys. So you can see it does look like it varies quite a lot from year to year. So, definitely something is going on, and it's related to the predator biomass. So even if you don't believe stock assessment, multi-species models, or think they're too complex or they're wrong in some way, it does look like stuff is changing that we should probably account for. Yeah, I also wanted, I know this is not about productivity really, selectivity, but I think we need to talk more about selectivity. We don't generally, we generally just ignore it. And many assessments, especially if they're a little bit variable and difficult to get them to converge, then you'll basically just assume that the selectivity is constant, and then your model is much easier to get convergence in. So it's generally, we just try to ignore it. It's not so interesting. These are examples for Northeast Arctic cod, so the Barents Sea cod that we had before. They're examples of yield curves with different selectivity patterns. So the long dash one is the existing pattern but moved 1 year below, so they're caught 1 year earlier. And the thin solid one is if you have the existing pattern and move it 1 year up, so you catch them 1 year later. And what you can see is basically if you look at the MSY and the precautionary Fs for the 3 different curves, it matters a lot if you change your selectivity. So basically, if you are waiting and catching your fish very late in their life, you can basically fish like hell because it doesn't really matter. And if you catch them very early, you tend to get the precautionary and the FMSYs to get very close together. So it is actually important what happens. But as I said, many of the assessments don't even report this or estimate it. So it's a little difficult to actually look into what's happening. But there was just last year, there was an STCF working group that happened to do all the work for us. So we don't actually have to do any real work ourselves. These are plots of the fishing mortality on the recruiting year class divided by the fishing mortality on other year classes. So the advantage of this as an indicator is it's independent of recruitment pulses, which is one of the problems. If you just look at the fishing mortality on recruits, you get these problems with recruitment pulses having an impact. So we really want to get rid of that. So this one is just basically telling you whether your selectivity pattern is changing, and it's 3 cod stocks and a saithe stock. So stuff that is caught in mixed demersal fisheries in the North Sea and the Baltic and west of Scotland. So you can see there's quite a lot of change in these patterns over time. And we still talk mostly about, productivity change for those stocks as well. So we need to talk about that too. But totally ignoring it, probably not a good idea in the long run. Okay, so let's conclude. Productivity matters. It doesn't necessarily do what we think or what the stakeholders think. And we know that the ecosystem stuff varies, the selectivity varies. Do we actually use all that information, or are we just writing papers and getting famous? Well, the first issue is whether there are studies done of the effects of, say, climate change, growth, recruitment, mortality on FMSY, and you get lots of those in the literature. So there are quite a lot of papers that, this is an example for the North Sea pelagics. It's basically looking at the decrease in mean length and recruitment of the different stocks. So there are 5 pelagic stocks, and they all have a decrease either in weighted age or recruitment, and that leads to a decrease in FMSY that's really large, so between 26 and 64% decrease in FMSY. So you have lots of studies. So there's a whole bunch of those. So you could pick whichever one. There are lots of those showing that it actually matters. But is it actually used? Well, the ICES guidelines state that you should the FMSY that you're using should reflect the status until the next update of the reference point. So in the next 5 to 10 years. So not, no predictions of 100 years in advance. Just, make sure you've hit the next 5 to 10 years, sort of okay. This should provide you with an automatic update, which is similar to what Andre was talking about yesterday, a moving window approach where you update every 5 to 10 years, and then you're lagging behind, but you are updating as stuff is changing. There are also, and I'll talk about that later, some flexibility with other ways of doing this, like adaptive management strategy of shorter time frames. They're also used, and I'll get back to those. But let's start with this. Do we actually do this, or what happens with the moving window thing if we ask the workshops to do it? So in ICES, what will happen is that you will have every 5 years, say, you will have a benchmark workshop for a list of stocks, and they will fix the reference point. So they will discuss and what's the evidence, what should we use, and have a look at that. So this is an overview of what I can't even count how many 10-something stocks have actually done with their reference points. So what is the year range they include in biological parameters, so weighted age, natural mortality, in selectivity, and in recruitment. And I should say that I didn't include that in this is for the FMSY changing, right? But a few of them have changed their B-limbs, but it's not common. Most of them keep their biomass reference points constant, so that doesn't really affect this FMSY estimation. Most of them use some kind of a moving window type, but the number of years they include is very different. So it goes from just 3 years for the herring in the Baltic Sea and the spread in the Baltic Sea, and up to 30 years of the Norwegian sea herring. So it's basically based on whether they find that there is a trend. So that's one of the things that affects it. But I think it's also based on whether they are using, the kind of method they're using when they want to include the weighted age in their MSE. If they're trying to bootstrap from observations, they normally want more than 3 observations, so they tend to go with a 10 or more. So there's a bit of like a trade-off between getting nice data for your simulation and trying to be as recent as possible. But in general, I mean, they do moving window stuff. And the stocks I showed before, like cod in the North Sea, has a 5-year selectivity window, so they also update in response to the change in selectivity. So, oh, I should say, sorry, it's just, we could also think about actually doing something really nice, like temperature or calenus or something that's predicted out of a climate model. That's not actually included in any of those. Some of them have correlations or like time series, autocorrelations in the time series, but not outside things affecting the estimates. Yeah, can we do maybe a little more adaptive? Do we have to wait 10 years and a benchmark to get changes, or are there stocks that are a little more inventive? So for short-lived things, they actually vary so much that you just need really recent information. So you're not predicting far away. So everything here is basically based on the most recent information you can get. So most of the fishing opportunities for the short-lived stocks are in-year assessments using the recent growth, mortality, selectivity, and some index of incoming recruitment, because you don't really want to estimate something that variable. There's one stock, the Barents Sea capelin, that expands this. It has a natural mortality forecast based on, based on cod biomass, so it doesn't observe in the hindcast in the same way. So there are some adaptations to it, but it's basically the most recent data you can get, we include that. If you look at longer-lived stocks, you can either implement F ranges, or you can do a predefined evaluated 2-step management strategies. So I'll just show those 2 options. And what are the ranges? Just to make sure there are a bit of ideas about what they could be. Basically, we had, as before, this is the MSY, the yield plot. It's just using the Northeast Arctic cod. If you look at the yield, there's a range of fishing mortalities that will provide you with 95% of the yield. It doesn't have to do with the uncertainty of your plot. It just has to do with the mean yield curve, or median yield curve, actually. Together, those provide you with a range within which the fishing mortalities provide you at least with 95% of MSY. So that gives you a range. And you still have this precautionary thing. The range can never be above the precautionary. So if the upper part of the range is unprecautionary, it's simply removed. So you end up with a precautionary range around FMSY that if you are an EU country, you can use the full range under certain condition. And if you are not an EU country, you can only use some of it. So when is it actually legal to go above FMSY? Well, or around FMSY. First of all, it's always okay to fish less. You can always do that. It's stated in the legal text. It's never okay to go above FMSY if you have a stock below your biomass reference point. So here again, it's handy to have a biomass reference point for North Sea cod, for example. But if your stock is above the biomass reference point, you can use the ranges if you have interactions between and within fish stocks, so some kind of ecosystem stuff going on. You can account for interactions in the fishing process. So if two stocks are caught together, you can have a little bit higher F on one and a little bit lower on the other one. Or you can have try to stabilize year-to-year variability in catches. Actually, if you look at how much request there is for scientific advice, it's very little. So basically, there is a request for mixed fisheries, but it's not actually used in decision making. So I think what ended up happening was that it was nice for the policymakers to have the ranges, but they didn't actually want any advice on where to go within them. So, because you can't stop scientists, they just move on even if you don't want the advice. One of the recent approaches is for the IWC is to use ecopath to determine if you are in a high productivity regime or a low productivity regime, and then you increase F if you are in high productivity or decrease it if you're in low productivity. So you sort of post hoc adjust within the range. So you stay within the precautionary range, so you don't need to do more MSEs during the process. And it's not actually in it's not implemented yet, but it's been suggested. So that's one way to be more rapid. Other things, well, you could also, first of all, it's really nice to look at the Barents Sea. It's a stock we all want, lots of fish there. You could also have the idea that we just put in, like, there's been some stocks where you put in a temperature predictor of something like recruitment. So this is a 15-year moving window analysis of the correlation between cod recruitment and temperature that Bjarne has done. And you can see it, and the black ones are significant. So you can see that looks pretty nice. Yeah, you would like to predict something. Even if you look at, and you add some years, it still looks, it's not necessarily significant for the 15-year period that you're looking at, but it's still, it looks pretty good. You might be able to use that. In this study, he also, unfortunately, had some older data. And it turns out that you have this correlation, but you have no clue for how long you will keep the correlation, because you can see in your historic data that you might actually not have it or even have a negative correlation in some periods in time. So it's not actually used. I think there's a reluctance in the ICES community to use the correlations for advice, even though we think there's probably a good reason that cod productivity is increasing when we have a higher temperature. It's probably limited by temperature, and there are lots of good biological theories about that. But even then, it's not actually used to predict recruitment. But what about density-dependent growth? Can't we do something about that? Let's, why is ICES not actually implemented, or we in ICES as scientists implementing something about density-dependent growth and predation? We should be able to do that with all the multi-species I've just showed. We should be leading the world on that. This is basically showing the relative fishing mortality of Baltic cod and I should say I picked this example specifically because it's an old Excel sheet that Henrik Gislason did. But it's the same result if I take the fancy models. So I think it's actually so nice and simple that he managed to get that result before other people. So the first that you can see is the black line is if you do single species FMSY, nothing affects anything. It's perfect. If you go for multi-species, the fishing mortality on the x-axis is what you fish the Baltic prey with, and that's going to affect your FMSY for your cod. And it's not just, it's, more than it's affecting. You also know that if you look at historical time series where you've had low predator stock size for most of the time, then including these multi-species interactions always lead to a higher F than your single species FMSY. So you're basically advising, we've had a long history of overfishing the stock, let's fish some more. And you can include growth, and then it gets actually even higher. You get even higher estimates of FMSY. And I think in general, there's been a bit of reluctance to actually increase fishing mortality this much for predatory stocks, which in general, in most areas, are actually still below biological reference points. So not really what you want to do at this point. So we're a little worried. But this is the Barents Sea cod stock. They don't have to be worried like the rest of us. They can be happy. So that you can see the SSB has basically gone through the roof. They've got so much fish they can walk on the water. But even there's actually concerns about overfishing if the stock returns to the low stock size. So you're still a little bit concerned, maybe over-concerned scientists here. So what can we do? Well, they came up with a two-step harvest control rule. they don't like to say where the F targets necessarily come from, but you can compare the numbers and see that what happens is basically if you're above the biomass reference point, you fish at something like FMSY. But if you are double that level, you increase up to something that is equivalent either to your multi-species MSY or your upper range of the FMSY. So you basically have an automatic extra conservative thing put in, because they could actually say that we have a really high biomass, so we want to go with the F at all biomasses, but they're putting in a harvest control rule that allows you to automatically update every year. And you can do your MSE on this and see that it's precautionary. So you can do the full round, but you now have 2 steps. Okay, so that's lovely. What happens when you actually use the dynamic reference points in communication of the state of the stock? So Andrea was talking about that we have 2 things we want to do with the reference point. We want to set the fishing opportunities for next year. That's one thing. So we talked about that endlessly, but we also want to communicate what's the state of the stock. How is it doing? This is an example of North Sea Saithe, and you can see the current FMSY is the red line, and we touched it, or we were at it, and then now we're above it again. But if you look at what happened in the 2012 assessment, it was the same stock size, but at that point the reference point was lower, and in 14 it was a bit higher, and then in 19 it was updated. So you get this shifting baselines about how well, how good were we at exploiting the stock sustainably. It tends to shift as you update your reference point. It's very difficult to actually explain to people who don't really work in this area generally. And what do you do with your cod in the Barents Sea, where we just saw that we have this fancy 2-step rule? So we have a red line here, that's the lower level of it. And that would seem to indicate that you have to be below the red line to be happy. But in our harvest control rule, it was evaluated that you can even use the higher one and still be in the sort of happy domain. But it's very difficult to communicate this. How do you actually tell this to people outside the advisory community? So the people that actually receive this, how do you explain to them that now it's okay to fish really hard? So you get new challenges, basically. You get rid of some challenges and then you open up for some other challenges. So summing up, well, I'm sorry, biomass reference points, not easy to estimate, is what we came up with. We didn't come up with an endpoint yet. We didn't come up with the perfect recipe, unfortunately. The Fs are estimated from the MSEs. They're updated more frequently, so it seems to be sort of more of an, it doesn't require so much expert judgment and tearing your hair out because it's difficult. You need to account for the year-to-year variability in the short-lived stocks. It's important, as are the biomass reference points related to recruitment. If you decrease productivity or you're short-lived, you need to account for your precautionary fishing mortality as well as your biomass point. So you sort of narrow down the scope of where you can be and safely navigate. And you do have rapid changes in FMSY, particularly, and we've seen this in several areas, if you have recruitment and growth failure and increased natural mortality. So that could be for there are lots of especially cod stocks that exhibit this. So you really need to keep track of if you have recruitment failure and growth failure at the same time, even if you don't know about natural mortality. That's that's danger. You have to do something about that quickly. I can just observe that we spent almost no time on selectivity pattern. The STCF group I was citing, it was not about the effects on FMSY. It's about whether the commission thought that they have done well in reducing fishing mortality on recruits. So it didn't have to do with the reference points at all. And the rest of us mostly just make the moving window and then ignore it. We don't really spend a lot of time on how we communicate the updates. So people get pretty confused when we actually update something. And I still have this issue with that everybody thinks that if they just incorporate the ecosystem and density dependent effects and all other kinds of things and update, it will all turn out to their advantage. But since the stakeholders want different things, it's probably not going to work out for everybody in the way they actually expect. So maybe a little disappointment afterwards. So I think that was all I had. Thank you. I hope you didn't fall asleep.